Hello everyone, I hope that you're well. Today I'm going to be walking you through a hard differential equations question. It's a 9-mark question. Pause the video now and have a go at the question yourself. This question is telling us to use partial fractions to find the general solution to the differential equation 2 dy over dx equals y minus y cubed for this interval, and it's telling us to give our solution in the form y equals f of x. So the first thing I'm going to do is I'm going to rewrite the differential equation just below it over here. So now we're going to want to move all the y variables to one side and all the x variables to the other side. So we'll divide through by y minus y cubed, and we'll divide through by the 2, and we'll multiply by dx. So we'll get something looking like this. dy equals half dx. And now we of course want to get rid of the dy and the dx's. So we'll integrate both sides of the equation. So we can integrate the left hand side of the equation very easily. It's just integrating half dx. And when we integrate that, we'll get half x plus c. So for the whole equation, we only need to have 1 plus c because we're adding one constant to the whole thing. Now let's try and integrate the right hand side of the equation. So we're integrating 1 over y minus y cubed dy. So we can't integrate this on its own. We're going to have to decompose it into partial fractions as it tells us in the question over here. For the decomposition into partial fractions, I'm going to change colour into red pen to keep it separate from the rest of the integration. So I'm going to factorise the bottom. It's going to be 1 over y, 1 minus y squared dy. And of course 1 minus y squared is a difference of two squares. So we can factorise that even further and we'll get y, 1 minus y multiplied by 1 plus y. So now we have three different terms that are multiplied by each other within the denominator, so we can decompose this into the partial fractions a over y plus b over 1 minus y plus c over 1 plus y. Of course the numerators all add up to equal 1, so we'll just write it as this, 1 minus y and 1 plus y. Okay, so we're going to try and find a, b and c, and to do that we're going to multiply the numerator by the separate denominators. So essentially what you do when you add fractions normally with whole numbers, we're just going to do the same thing now. So we'll get a multiplied by 1 minus y multiplied by 1 plus y plus b multiplied by y multiplied by 1 plus y plus c multiplied by y multiplied by 1 minus y all equals 1. So I'm quickly going to expand this. So that's going to be a minus ay squared plus by squared plus cy minus cy squared equals 1. So we can deduce from this that a equals 1 because the whole number a equals 1. By plus cy equals 0 because there's no y variable or something containing the y coefficient on the left hand side. And minus ay squared plus by squared minus cy squared equals 0. So over here we can just divide by y and we'll get b plus c equals 0. And here we can just divide by y squared and we can get minus a plus b minus c equals 0. We know that a equals 1, so that's just going to be minus 1 plus b minus c equals 0. And then we'll just add on 1, we'll get b minus c equals 1. So we have two simultaneous equations to work with. b plus c equals 0 and b minus c equals 1. We can add these two simultaneous equations together and we'll get 2b equals 1. So therefore b equals a half and c equals minus a half. So we can write the fraction that we were trying to integrate now as 1 over y plus 1 over 2 lots of 1 minus y, because of course b is a half, minus 1 over 2 lots of 1 plus y, because of course c is minus half, dy. So I'm going to rewrite that up here and we can focus on integrating it now. Now I've got what I'm trying to integrate, I'm going to switch back to the blue colour. So we have 1 over y plus 1 over 2 1 minus y minus 1 over 2 1 plus y dy. We can integrate, there's just the standard integral 1 over y is just going to be ln y. When we integrate 1 over 2 1 minus y, we'll get minus a half ln 1 minus y. And when we integrate this, we'll just get minus a half ln 1 plus y. Remember, the left-hand side of our differential equation equals the right-hand side of our differential equation. So this equals this. So we'll equate them together. And then we will use a lot of algebraic manipulation to write it in the form y equals f of x. So I'm going to move over here. We have ln y minus a half ln 1 minus y minus half ln 1 plus y equals half x plus c. So the first thing I'm actually going to do is I'm going to multiply through by 2 to get rid of the half x and the half ln's. The c will always just be a constant, so we can just leave that and forget about it right now. So we don't actually have to apply the times 2 to it because it was just a constant. So times 2, that is just going to be 2 ln y minus ln 1 minus y minus ln 1 plus y equals x plus c. Now what I'm going to do is I'm going to factor out minus 1 from ln 1 minus y minus ln 1 plus y, so I can just get ln 1 minus y plus ln 1 plus y equals x plus c. So now we get 2 ln y minus, when we have two logs plus added to each other, we can just multiply them and we'll get ln 1 minus y squared, because remember it's just the difference of two squares, equals x plus c. 2 ln y we can rewrite that as ln y squared, and we're minusing it by ln 1 minus y squared, so we can just write it y squared over 1 minus y squared, because when you minus natural logs or any logs, you just divide what's inside the brackets, equals x plus c. So remember, the question is asking us to write it in the form y equals f of x, so we're not quite there yet. So we're going to want to remove the natural log function, so we do y squared over 1 minus y squared equals e to the x plus c, which is the same as e to the x multiplied by e to the c. So when we look at this, we know that e to the c is going to be our constant, so we'll call e to the c a. A is just a constant. And we can just say y squared over 1 minus y squared equals a e to the power of x. So to get into the form y equals f of x, we're going to have to do more algebraic manipulation. So the first thing I'm going to do, I'm going to multiply through by the denominator. So we'll get a e to the x minus a e to the x y squared. I'm going to add this a e to the x y squared to this side, and we'll get y squared plus a e to the x y squared equals a e to the x. And now I'll factor out y squared, and we'll get 1 plus a e to the x equals a e to the x. And now we can divide through by the brackets, and we'll get y squared equals a e to the x over 1 plus a e to the x. And now we can simply just square root it, and we'll get a nice function a e to the x over 1 plus a e to the x. So this is actually the form the question was asking us, y equals f of x, because we have y in terms of a function with x in it. And that is the general solution to this differential equation. So I'm quickly going to go through each of the separate marking points to show you how much you would have scored with however much working out you did. So you get 1 mark for writing it in this form. You get another mark for setting up partial fractions in a reasonably correct form. So you get another mark for that. So you get another mark for actually finding out the values of a, b and c. And then you get another mark for writing out the partial fractions in this form. You get another mark for integrating the left-hand side of the differential equation correctly. They give you one other mark for at least using one log law correctly. You get 1 mark for obtaining a correct expression without logs. You get another mark for obtaining a reasonable expression in the form y equals f of x by using the reasonable method like we've used over here. And we get the final mark for obtaining a correct expression for y. So that is all 9 marks. I'll zoom out so you can get a picture of all the working if you need to, or if you want to. I hope you found the video useful. Thank you for watching.